Welcome back students. Today we are going to see about inductor. What is inductor? Inductor is an energy storing element as well as capacitor is also energy storing element. Inductor stores the energy in magnetic field. It stores the energy in magnetic field and the capacitor stores the energy in electric field. Both are energy storing elements, but in which domain they are storing the energy is the matter. Okay, so see, consider here. Now I'm going to consider an inductor. Inductor is nothing but a coil. Okay, so I'm going to pass some current through the inductor. What will happen over there? So the inductor generates some flux around it and stores the energy. Okay, so we can write the inductor voltage VL is equal to inductor L and the rate of change of current. See here, what is di by dt? Di by dt is nothing but rate of change of current with respect to time. The current is varying with respect to time. So now I'm going to consider, I'm going to write the formula for di. So how I can write di? We want to cross multiply this dt there. Okay, so di is equal to VL, okay, into dt divided by L. So we can also write this as 1 divided by L V dt. You can also write V, otherwise in subscript you want to mention L, that is inductor voltage. So VL. Okay, so this is nothing but what? Current, differential current, rate of change of current. If I want to consider the current, normal current, this is differential current Di. If I want to find the current, we want to integrate on both sides with respect to time. I want to integrate on both sides, then I will get the current. Here the time is variable, so I am going to differentiate from 0 to t. So what will I get? Here upper limit minus lower limit, so I of t minus lower limit is 0. So I of 0 is equal to 1 by L is constant, because the inductor value is constant now. So I am going to take that out. So 1 divided by L integration of 0 to t v dt. Okay, so what is the value of I of t? I of t is equal to 1 divided by L integration 0 to t v dt, and take this term this side, so it will become plus I of 0. Here what is I of 0? I of 0 is nothing but initial current in the inductor. Initial current in the inductor. Okay, so we all know the formula for power. What is the formula for power? Power P is equal to VI, right? So power P is equal to V into I. Here nothing but inductor voltage. We already wrote this here. Okay, so what is the value of the V inductor voltage? L di by dt. Yes, so instead of V I am going to write L di divided by dt. Already I is here, so I. This is nothing but power. So if I want to calculate the energy stored in the inductor, means what is the formula for energy? So energy stored in the inductor E, otherwise we can also, in some books they wrote as W, that is energy stored in the inductor. How we can write the energy stored in the inductor? So W, that is dW is equal to energy is equal to power into time taken. So power is already there, power into time taken. Here dW, so here I am going to write dt. So substitute the value of P over here. So what I can get? L I, this I will bring in the front. So di by dt, this power value I am going to substitute here, into dt. Here it is dW. Okay, clear? Let me, yeah. So cancel these time values, and what we will get? dW is equal to L I di. So integrate on both sides, we will get the value of the energy. Okay, that is W. integrating on both sides. So here differentiation integration gets cancelled. So what we will get, differentiation integration get cancelled. W is equal to L is constant value. The inductor value is constant here. Take it out from the integration. So I di. You all know in the integration, if I am having x dx means what is the value? X power 1 plus 1 divided by 1 plus 1. X squared by 2 is the answer for this. So similar to that, instead of x, here we are having I. So how we can write? L I squared by 2. So 1 by 2, I can write 1 by 2 L I squared. This is the formula for energy stored in the inductor. So inductor means you want to fix your mind as current. If there is a capacitor means you want to fix voltage. Okay. So similar for inductor, the energy stored in the inductor is W is equal to 1 by 2 Li squared. If I am considering here the capacitor means, guess what the answer will be for the energy? W is equal to 1 by 2 capacitor C. There you want to consider the voltage instead of current. C V squared. Okay. Let us do the derivation too in the next session. Okay. Clear? Thank you, students. And once again, I want to tell one more thing. See here, if so some points we want to conclude here for the inductor. So inductor means it stores the energy in magnetic field. Stores energy in magnetic field. Okay. And again, if see here, if the current I am sending through the inductor is a constant means, that is, it is a DC current means, if it is a DC current means, what would be the rate of change of current? If I am differentiating a constant phi means, what is the value? If I am differentiating the constant means it would be 0. Similarly, if I am differentiating the constant current di by dt means what would be the answer? 0. So if it is 0 means the voltage is also what? The voltage is also 0. So if DC current through inductor means what will happen? Voltage is 0. Voltage is 0. So inductor acts as at that time. Voltage 0 means yes, short circuit. Voltage is 0. So for DC current, inductor acts as short circuit. But even though it's acts as short circuit, it will store some energy. See here the formula for energy. What is the formula for energy? Energy stored in the inductance. What is the formula over here? W is equal to 1 by 2 Li squared. It does not depends on the voltage. It depends only on the current and the inductor value. So even though the voltage is 0, the inductor acts as short circuit, it stores some energy. Okay. Even though it's short circuited, it stores some energy. Even short circuit for DC current, it stores energy. Okay. And one more point, if the time variation is very small, if for the 0 second the current abruptly change means what will happen? For the 0 time means anything divided by 0, infinity. So what will happen? The voltage is infinite, which is not possible. You want to consider this too. Okay. So this all, let me consolidate. So inductor stores the energy in magnetic field, and for the DC current, inductor acts as short circuit because the voltage is 0. But even though short circuited for the DC current, it stores some energy. So okay, let comment over this video. If you like this video, please share with your friends. Thank you, students. In the next session, we will discuss about the capacitor. Thank you very much for watching.